Ladies and gentlemen, good afternoon. I'm very glad to speak here. Today, my topic is purpose-driven modeling and analysis for SmartTable field and design based on DIKW. I will introduce to you from the following 4 parts. First is the background. Nowadays, people are faced with various forms, no matter on the internet or real life. The form is designed for various purposes. It involves the law, morality, and ethics problem. It also involves the interests of individuals or organizations, and there is a game between stakeholders. However, the content resources we can obtain when filling in the form are often inaccurate, incomplete, and inconsistent. In addition, the objects we study will have different cognitive differences for a certain content that is essentially the same. For example, people in equatorial and Arctic regions will have different cognitive differences for the objective existence of snow. This will make it difficult for us to deal with the content in the process of filling in the form. The existing research and technology are mainly divided into 4 parts. Some studies have evaluated the spreadsheet technology. Their research results show that the current technology needs to address many different needs. Some scholars have studied from recognition and proposed some methods, and designed a relevant traversal algorithm to locate and mark the form items. However, in the absence of content, there are few studies. Ignoring inconsistent, incomplete, and inaccurate things. Most automatic form filling methods are implemented by defining rules, but the application is limited. The main contents of our research include map the uncertainty related to concept semantic cognition in the form filling interaction to DIKW. Then establish a purpose-driven model to handle and meet the object purpose. Conduct subjective and objective content search and reason. We carry out DIKW-oriented classification mapping for the content resources of form maker and form fillers, and build the DIKW model. We define differences of DIKW model. Content differences include essential content, existent form, and meaning. Cognition difference include positions, cognitive distance, and relationships. We built purpose analysis system to determine the relationship between input and output of purpose, analyze typology of purpose, evaluate implicit purpose, analyze purpose conflict in object interaction. We built a DIKW map of content and cognition and carry out integrated reasoning of content and cognition, shorten the cognitive distance between problem input and the result output, reduce the cognitive uncertainty in the interaction process. Then I introduce our methods. We process the input of purpose and D graph, I graph, K graph, produce Curtis product. Knowledge rules in K graph play a role of inference and constraint in Cartesian process. And W graph judges the value of the reasoning result and the Cartesian set formed, thus generating a Cartesian set that conforms to the path or condition from the purpose input to the output. For example, in the case of travel reimbursement, we map form to input and output nodes and establish a purpose system. Analyze the part of speech, syntax, and content dependency of the content provided by form filler, and establish the content map and purpose system of the form filler for data, information, and knowledge, deduction, and supplement. This is the data and information map of the content and cognition of the keys. This is the part of the knowledge rules and the value judgment of the case. We first analyze the purpose system of the two. We find that there is no conflict between the output nodes of the two systems, and there is no need to segment the form node. And the form filler node has high priority and can be used as constraint or input for the form node. We propose a purpose-driven reading and supplement methods of form fillers on DIKW system. For example, according to the constraints of the purpose, book ticket, and related knowledge and value judgment, it is deduced that Tom buy a ticket to go to Shanghai by airplane. We propose a purpose-driven search and reasoning method for the form problem input and use the essentially related content and cognitive structure of the form filler to carry out cognitive reasoning for the form side. Finally, to summarize, we map the uncertainty related to concept, semantic, cognition to date, information, knowledge, wisdom, and purpose. We built a DIKW+P-based interactive model for filling in forms and designed content, reasoning, and completion methods. In the future, we will build a comprehensive trust DIKW chain architecture of trust data, trust information, trust knowledge, trust wisdom decision, which will be consulted with a progressive DIKW blockchain, data blockchain, information blockchain, knowledge blockchain, wisdom blockchain. Thanks.